Hello, everyone. I hope that you're doing well mentally and emotionally and physically. I know sometimes school gets tough, but if you need any help, there are plenty of adults in this building that are willing to help you. If you need help, just ask me, and I will do what I can. But today I want to go over how to balance a nuclear equation. You've already done the notes over what is radioactivity, how do we detect it, what are the main types, so make sure that you're reviewing that. For these, I want you to take the notes in your notebook, in your binder. I want you to keep those in your binder and then show me so I can check off that you've done the practice. Okay, these are things that you will need to know for quizzes and tests. Okay, so in nuclear equations, we are dealing with the nucleus of the atom. That is the central part, the middle. That's where all the mass is. The protons and neutrons there, and many other particles. But in chemistry, we're only interested really in 4 different particles. So we're not interested in the electrons. Those are on the outside. That's for ordinary chemical reactions. What we are going to do is what changes the nucleus? What changes one atom into another? We're always starting out with reactants and we're ending up with products. In a nuclear equation, what we're looking at is the atomic number and the atomic mass. So what you need to do as you do these equations are know that the total mass of the reactant should equal the total mass of the products. And same for the atomic numbers. Okay, some of the things that you need to know is in a chemical symbol, what do things mean? Okay, this is the mass number. A lot of times we put the letter A just to indicate that is the mass number. Z, they use that. Don't ask me why. They have their own reasons for doing that. So mass number is protons plus neutrons, and those are the 2 heavy particles. The Z, or the number that's in the lower left-hand corner, that's your atomic number, and that's the number of protons. And remember that electrons really don't matter here. If we had a charge, it'd be up here, but we're not interested in charges. And then X just represents whatever symbol that element is. So if you look on the periodic table, the symbol, for example, let's try copper. Copper is the symbol. This is the atomic number. Now notice here, when we write it on paper, we switch it around. We always put the mass at the top, which is the larger number, and then the atomic number at the bottom. Periodic tables are different. The one this particular one, it has the atomic number at the top and the atomic mass at the bottom. So you can always see this if you forget. Okay, so 29 would be the number I would put instead of Z. And then A is the mass number. I'm usually going to give you that because we're dealing with radioactive elements, and that will be different than the mass here. The mass on this periodic table is an average. Okay, so sometimes we can use the average if we're not given the mass, but most of the time I will give it to you. Okay, some of the symbols to know. These should also be in your binder in the notes that we previously did. If you did not do those or just want a little refresher, this is what you need to write down. If you already have it, that's fine. Just understand them. So you have alpha, which is this little fish sign. That's a Greek letter A, and the numbers are 4 and 2. That means that the mass is 4 and the atomic number is 2, which means there's 2 protons, and 4 protons plus neutrons. I can also write it with the symbol He for helium, so you may see it either way. I prefer the Greek letters, but you will see these also. Okay, so the alpha is made of 2 protons, 2 neutrons. It's big and heavy and slow in the atomic world. Okay, beta has 0 mass, and it has a -1 because it has, basically it's made of electrons, so it's the opposite of a proton. You have gamma, which is pure energy. This is a Greek letter gamma, 0 mass and 0 protons. We usually don't write this in nuclear equations because all nuclear equations produce gamma, and so we just tend to assume that it's already there. So you will not see it written, but know that it is there. Okay, here's an example of a nuclear equation. We're starting out with an atom. We may start out with 2 or 3. it's going to change into something else. It may change into 1, 2, or 3 or more things. But the main thing is that you have a mass and you have an atomic number. Okay, so where do we get the atomic number or the symbol? If you'll look at this, number 90, 90 is right here. So thorium will always be 90 at the bottom. The top number can change. Here it is 232, which matches, but it doesn't have to. This can be different from the periodic table. What this is doing, it's breaking up into two particles. Okay, an alpha particle and radium. Okay, what you need to know is that you need to add and compare reactants versus products. The atomic number will tell us what element. So, for example, on the left side, the reactant side, the mass, total mass is 232. What I usually like to do is cover up the bottom, and that way I'm focusing only on the top. So 232, this is kind of like equals 4 plus 228. So these added together should equal that. If I do the bottom, the same thing. 90 equals 2 plus 88. Okay, let's suppose that I'm not given this number. I come up with 88. How do I know it's Ra? Because I look up 88, and it tells me that it is radium. Okay. Okay, let's try some examples. Okay, so here I've got francium. It's radioactive. It is going to lose a particle. So I can write this different ways. I can put negative, I could put minus the beta, or I could put it over here. So just go by what the equation is telling you. Usually you'll be given like a box, or maybe a blank, or maybe there's nothing there. So what you have to figure out is, what is this forming? So I'm taking this francium and I'm taking away a beta particle. We're going to call that beta decay. Decay is when it splits up. Okay, if you don't know that, go ahead and write this down. You need to know what decay and bombardment means. Decay is when an atom splits apart, and it's also called fission. Bombardment, that is when an atom's joined together, and we call that fusion. Okay, you should have seen that before, but I don't think we covered those two terms. Okay, always pause your video, write something down, and then restart it. Okay, so let's go back to this. I've got 230 minus 0. Well, let's do the math on that. Again, let's cover that up just so we're not getting confused. 230 minus 0, that's going to give me 230. And I'm going to write that at the top. Okay, the bottom numbers, 87 minus a negative 1. Here's where your math class comes into play, where if you're minusing a negative, it makes it positive. So 87 minus a negative means 87 plus 1. So that would give me 88. Okay, now I have to find the symbol. So I take the bottom number, 88, and I look right here. 88 is Ra. Okay, so I'm going to put an Ra right there. And that is my equation. Okay, let's try another one. On this one, I have carbon 14. I can also write this carbon dash 14. That's not a minus, it's a dash. So if you see it written this way, that is the way you write it. How do you know the bottom number? Again, you look at the periodic table. So carbon has 6 atomic numbers. That's the one that goes at the bottom. Okay, I'm going to find out what it turns into. So it's going to turn into something plus this, and this is another way of writing beta. Okay, so I have to do 14. So 14 equals something plus 0. Well, it has to be 14. Okay, let's look at the bottom number. 6 equals something minus 1. Okay, if I put 13 here, 13 minus 1 would not give me 14. Okay, so what I need to do is 6, confusing myself here, 6 equals something minus 1. So If I put 5 here, 5 minus 1 would not give me that. So I'm going to put 7, and then I'm just going to check. 7 plus negative 1, that means 7 minus 1. Does that give me 6? Yes. Okay, I'm going to look up 7 on the periodic table. 7 is nitrogen. And I'm done. Okay, let's go to the next one. This is the same reaction that was in the lab that I did with the smoke detectors. This is americium. And it would be americium 241. Okay, so let's do the top numbers. And I'm going to do 241. 241 minus something would give me 237. So 241 minus what? Minus 4. And then let's check. 4 of 241 minus 4 give me 237. Okay, let's find the bottom numbers. Okay, 95 minus something is going to give me 93. 95 minus 2, okay, is that right? 95 minus 2 gives me 93. Find what element it is. I could either write He, or I could also write it 4, 2, alpha. Either one is correct. Okay, let's write the next one. This is a little more complicated because we have a large number in front. This large number multiplies both the 1 and the 0. So here I would have 3 at the top, and 3 times 1 is 3. 3 times 0 is 0. Okay, so I have all of this equal to all of this. I need to find the missing numbers. Well, first of all, let's find out what is the number on the top. What is the sum? So 235 plus 1, that gives me 236. Okay. So if this side equals 236, all of this added together has to equal 236. This plus that plus that. All right, let's do the math. So 146 plus 3. I already have 146, and I have 3. So add those together, that would give me 149, right? So now 236 minus these two added together, 149